Bismillahirrahmanirrahim. In this video we shall discuss about upthrust and buoyancy, Archimedes Principle, and how to find out the density of unknown object by dipping it into fluid. So let's start with upthrust and buoyancy. When an object is partially or completely immersed into the liquid, it experiences an upward force known as upthrust or buoyant force. Let we have a glass of water and we immerse a cylindrical object into it. So viewers, there are two forces acting on the object. Upward force is upthrust, while the downward force is the weight of the object. We are familiar with the relation for the pressure in the liquid, that is P equals to rho times G into H, where H is the depth of the liquid.
The depth from the top part of the cylindrical object is H1, while the depth of bottom part of the cylindrical object is H2.
So the pressure at the top of object is P1 rho times G
into H1, while the pressure at the lower side of the object is P2. Since the depth H2 is greater, therefore we can conclude that P2 is greater than P1.
Due to this pressure difference, an object tends to move, so buoyant force results. So viewers, what about the magnitude of the force? To understand how many newtons of upward thrust force is acting on the objects, let's move on to Archimedes Principle.
According to the principle, an upthrust force must be equal to the
Weight of the liquid displaced by an object. To understand the concept, let's take a spring balance and measure the weight of the object.
Assume that the weight of the object in air be 20 Newton.
When we partially immerse the object into the liquid, it displaces some water obviously. Let's take a balance and measure the weight of the liquid when the object was partially
dipped into the liquid. The difference in the weight in figure A and B can be observed by measuring the weight of the liquid displaced, that is 6 Newton.
So using Archimedes principle, we can conclude that buoyant force is of magnitude 6 Newton.
Similarly, when we take the beaker of water from figure C and measure its weight, it came to be
10 Newton.
Here we can clearly see that the volume of object and the liquid displaced are always same.
So viewers, do you know that why large ships float on the surface of ocean while very small piece of needle sinks into the water? To understand the concept, let's understand the concept of principle of flotation.
There are two forces acting on a body.
Force due to gravity, that is weight, and upthrust or buoyant force.
When buoyant force exceeds the weight of the object
Floats on the surface of liquid.
When buoyant force equals the weight of the object, an object remains suspended in the liquid.
That is, buoyant force equals to weight. When weight of the object exceeds the buoyant force, an object sinks into the liquid. That is, F buoyant is less than weight of the object. Finally viewers, we will discuss how to find out the density of any unknown object by dipping it into the liquid. For the purpose, we must take the ratio of weight of the object immersed into the liquid to buoyant force. Let the weight of the object which was immersed into the liquid was W and weight of the liquid displaced by that object be FB. So the ratio becomes MO times G by MB times G. G cancels out from numerator and
denominator and we get MO by MB.
For now, we will label the fraction by equation 1. Here MO is the mass of object and MB is the mass of the liquid displaced. As we know that density is mass over volume, so mass can be written in terms of density and volume as M equals to rho times V. As we discussed earlier that volume of the object and volume of the liquid displaced are equal. So the fraction in equation 1 can be written as rho O V by rho B V. Again V cancels from numerator and denominator and finally we get the ratio
rho O by rho B. Knowing the density of fluid, we can calculate the density of object simply by using the relation. Thank you viewers for watching us. Don't forget to press subscribe button and